Good morning, everyone. Welcome to another session in Container Series with AWS UGNCR. My name is Dipali, and I'm one of your hosts for today's session. I'm User Group Leader for Delhi NCR and Certified Solutions Architect Professional and AWS Hero. I'm joined by Rajat Arora. Rajat, would you quickly like to introduce yourself, please?
Sure. Thanks, Sepali. Hi, everyone. Very good morning. And today we are here to do the demo and discussion on AWS ECS, which is one of the most popular container management service by AWS. And some introduction about myself. I am working as a vice president in NetWest and managing a cloud technology department there. I am two times AWS Community Builder for 2023 and 24. I am also a user group leader for Delhi NCR, AWS Delhi NCR, and we are doing all these community activities for the AWS UG NCR group. And yeah, let's go ahead with the session.
Sure, Rajat, thanks. So, for today, we will be doing a quick recap on containers, which we have covered in our previous session, and I will share the link shortly. And then we will discuss the key problems when we try to manage these containers at scale. And then we will dive into the concepts of ECR and ECS, which are like container management tools available in AWS. And as Rajat mentioned, after we discuss these concepts, we will dive into the demo and followed by Q&A. So before we start, do we have any questions, guys? Please post them into the chat box and try to keep this session interactive by lots of questions and try to be active participant throughout the session and so that you can win a chance to so you can get a chance to win like not goodies but AWS credit this time. All right. So containers, a quick overview. So, as we discussed last time, containers have revolutionized the way we develop, deploy, and run applications. Containers allows us to package an application with all its dependencies into a standardized packet or a standardized unit, which is known as container. However, managing containers, especially at scale, it requires powerful tools. And these tools are provided by some of the prominent container providers that are widely used in the market today. And each of these providers offers some unique features and capabilities and making them suitable for different use cases. So we discussed Docker in detail last time. So Docker is one of the most powerful container service. So Docker is one of the most powerful container platform. So Docker makes it easy to create, deploy, and run applications in consistent environment. So you can run your application either in cloud or on premise or different flavors of cloud, whether it is AWS, GCP, Azure, etc. So its simplicity and powerful tooling have made it so popular in the market as like we as software developers prefer to use Docker in the container ecosystem. Then next provider in this category is Podman. So Podman is a container engine which is developed by Red Hat. It is compatible with Docker, but it also offers some distinct advantages, some additional features. It runs containers as like regular user processes which don't need any daemon. So and it with that it also enhances the security. So it is another interesting tool to manage containers. Then we have Kubernetes kind. Kind stands for Kubernetes in Docker. So kind is a tool for running local Kubernetes cluster using Docker container nodes. It is primarily used for testing and development purpose. So it provide a lightweight way to create and manage Kubernetes cluster on local machine. Then we have Amazon ECS, and sorry about this typo here. It is ECS. So this ECS is a fully managed container orchestration service provided by Amazon. ECS simplifies the process of running, stopping, managing containers on the cluster, and we will discuss it in detail in today's session. Then we have EKS, which is AWS Elastic Kubernetes Service. It is a managed Kubernetes service which makes it easy to run Kubernetes on AWS without managing any control plane. And we will discuss about that in detail in our future session. Then we have Red Hat OpenShift, which is a Kubernetes based container orchestration platform which offers a range of additional features to enhance the Kubernetes experience. OpenShift include an integrated CI/CD pipeline as well, developer tools, and advanced security features. So these are some key features which these container provider provides, and depending on our use case, we can choose any one to use. Now, key problem which we face. Okay, sorry. Before that, we have a glimpse of previous session which we have conducted in this series. So the first session was around microservices, so its YouTube link is available here, and the second session was on containerized with AWS, where we specifically dive deep into the Docker, so its link is available here.
So in this sessions, you can go through and understand the basics of microservices, what is a container, how to do the lifecycle management with the container, which is like creating images, creating a Docker container running on your local system or on your EC2 machine, so that you can set up a base for this session. And in this session, we will particularly focus on ECS, like how to convert and how to run your services on Amazon ECS cluster. So that so if you need to do a hands-on for today's session, it would be preferred and advised to go through the previous session and follow them till this point.
Yeah, all right. So now let's talk about that, like what are the challenges we face when we try to manage multiple containers at scale, because it is a critical aspect of application deployment and orchestration when we think for production like workloads, because our applications, they keep on growing and become more complex and complex. So it becomes very essential to efficiently manage these numerous containers. So you can imagine that you have these number of containers to manage. So definitely you need some tools so you can streamline various aspects of managing containers, and these aspects can be, for example, container orchestration, load balancing, scaling, logging and monitoring, security, CI/CD, etc. So there can be a number of things which you need to manage for an application. So, so to manage this level of application, which is comprised of hundreds and thousands of containers, you definitely need some tools.
So you can think it of as like if you are running a Docker container on one of the EC2 machine, then you're good. But what if you need to make your application scalable? You need to make it horizontal scaling. If you want to set up multiple EC2 instance and you want to run different containers on them, so how you manage multiple Docker instance, how you can use the benefit of load balancing across multiple availability zone for high availability. So these are the concepts that you can do with basic EC2 machine. Now today we'll talk about like how you can all use all those features, which is horizontal scaling, scaling across multiple availability zones for high availability. That is what we will learn in session today.
Okay, so Docker Swarm. So what happens, if you need to quickly set up a container orchestration environment, so Swarm is a great option because you can spin up an environment with minimal configuration. You can add nodes and deploy service uh, rapidly, I would say. So Swarm is used for natively managing cluster of Docker engines, and so this is a suitable tool when you have tight timelines, or when you need to do some prototyping for your application. So you can quickly set up this environment using Swarm, and can complete your POC. But yes, it is not preferred for production scale applications. Rajat, do you want to add something here? Rajat, you are on mute in
Yeah,
case you are
sorry, I was
speaking.
on mute. Yeah. So Docker comes up, it's its own Docker engine, which is known as Docker daemon, which is responsible for creating images, managing the life cycle of images, and it also manages the cache for the images. Then it manages the container lifecycle. It allows you to run containers on the EC2 machine or on your local desktops. So in the same way, there is a tool which is natively provided by Docker Swarm, in which what you can do is like you can set up Docker on multiple systems. Like if you have two different laptops, you can set up individual Docker on them, and you can set up a Swarm to make one of them laptop as a master node, and from that master node you can deploy your docker containers on any of those laptops. So this is a tool, this is an orchestration tool provided by Docker itself, but it is not that much scalable or that much popular in market because it comes with a very basic features. So that is where we need high level systems like Kubernetes or other systems to manage containers in a better way. And in a similar way, we have an ECS service today, which is specially designed by AWS to manage and orchestrate containers on cloud.
Yeah, but before we move on to the ECS, because ECS is a container management platform and ECR is a registry where we can store our images. So let's talk about ECR first. Raja, do you want to continue?
Yeah, sure. So let's understand how we actually ship the images or how we actually ship the containers from one system to another system. So the base concepts of using Docker containers is like it runs on my system and it can run anywhere. So you create a package, you create a package name container which consists of everything: source code of your application, various configurations that you need to provide to your application, the dependencies that are required for your application, any pre-installed runtime environments like Java SDK or JRE, or any certificates that you want to ship with your application. So it is a complete package which just does not include your source code. It includes all the configuration as well, so that it can run as a isolation unit anywhere. So it is working on your system now, but now the main question is like how we can ship it to the other system. So if it is working on my laptop, how I can deploy it to my dev environment on some of the cloud EC2 machine, or my UAT environment which is running in inside a VPC on a cloud environment. Maybe it could be a Google Cloud or Amazon Cloud. So how we can actually ship it? Then comes a concept of a registry. So Docker registry is a way where you can upload packages which is known as image, and then you can use those images on other system. You can download those images on other system and you can run it. So Dipali, if you can open your browser and you can visit hub.docker.com. So Docker registry is the very base unit or the first service that you will use across. So this is available freely over internet, and in this you can go and create your account, and within your account you can create two type of repositories. One is known as public repository, which means whatever images you publish here, they will be available to everyone. And the other one is a private registry, like so whatever images you upload, it will be available only to your user account when you log into it. So there's no need to log in, you can just go to the previous screen, search for any of the image like Mongo. Just search for an image Mongo. Just for an example, we have covered this in detail in the previous session, so in case you missed that, you can go to the previous YouTube sessions. So this is a Mongo image, or you can say like this is a Mongo package which someone has created on their local system and they have published it on Docker Hub. Now you can use this image, you can use Docker pull command, you can download this image and you can use it in your environment, whether it will be your local system, whether it will be your AWS cloud environment, or it will be Google cloud environment, because all these Docker containers are platform agnostic. So in the similar way, if we go back to the registry, so when you're working on the, yeah, go back to the slide. So when you want to work in an corporate environment or an enterprise environment where you want to manage lot of images specific to your organization, So how you can do it? One is like you can upload all those images to Docker, which is not a right way because it is publicly available and all your organization code would be exposed outside your organization. Even if you create a private registry, private repository on Docker, but you're still pushing your code from your organization to the third party organization, which is Docker. So there are a lot of I would say company guidelines or security guidelines which does not allow organizations to push your source code or your packages to the public internet. So that's where Amazon has created a special container registry known as Elastic Container Registry. This container registry is specific to your account. You can go inside your AWS account, you can create a registry which is known as Elastic Container Registry. We'll show that in the demo. And then you can manage the life cycle of images with this registry. You can publish your images, publish your organization images on your AWS account. You can manage them. It is automatically encrypted by AWS so that they will provide security at rest, security at transfer as well. So both the services are provided by Amazon, and these services are very much integrated with the solutions provided by Amazon, which is like if you are using any EC2 machine and you want to run container on EC2 machine, so Elastic Registry is very much compatible and integrated with that. The other option is Elastic Container Service ECS. So this is also available where you can use your images, and we'll show that in session today. And the third option is Amazon EKS, which is Elastic Kubernetes Service. So you can upload and publish your images to Elastic Container Registry and you can run Kubernetes cluster from that. So over to the next slide. So as I showed you, like in Docker, you can create two type of registry. One is public and another one is private. So in the same way, on Amazon also you can host a public repository or you can host a private repository. So public repository, in case you are a vendor or you are a software distributor, so you can use public repository. You can publish versions of your software, something like WordPress or Jira or Bugzilla, so that you can provide it to your customers, and your customers can download those images from public repository from your AWS account, and they can run it on other AWS accounts or on their own local system. It is publicly available anywhere. But in case you are creating images which is specific and private to your organization and you want to share it within organization only, then you can take a users of private repository. What are the main benefits of using Elastic Container Registry services? It is fully managed. It means you don't have to do any infrastructure management around it. You don't have to do anything around load balancing or high availability. It is a very high available service. In the background, Amazon manages. You just need to push your images and you can manage complete life cycle. You can do tagging, you can do version management, you can do lot of other things with ECS. It is very secure. It does lot of encryption while transferring of images over HTTP. It encrypts it at rest as well, as I mentioned. Like Amazon encrypts it in the background while your images are stored on the background storages. It is very high available service. Amazon provides 99.9% availability of this service, so that it will never be down. And it's a very simplified workflow. You can manage it via I would say some source code management tools as well. Some SDKs provided by Amazon, CLI is provided by Amazon. So it is very easy to manage. So this is a sample of the Elastic Container Registry repositories that we are going to create today. You will see the screen very shortly in the demo as well. But this is how it looked like. So we created a private repository and then we publish few different images onto it. So this is how it will look like. Okay, over to you, Dipali. Dipali, are you on mute?
Sorry, yes, I
Yep,
was.
we can hear you. No worries.
Okay, so now let's discuss about AWS ECS, which is Elastic Container Service. So ECS is a like fully managed container orchestration service, which is provided by AWS. It makes it easy to run, stop, and manage Docker containers on a cluster of EC2 instances, or we can also use it in a serverless way using AWS Fargate. And we will see all these things in a while. So, like ECS, as I mentioned, like it's a cluster management. It is used for like cluster management, container orchestration, and it is well integrated with other services within the AWS ecosystem, as Rajat just explained. Now, how ECS works. So, you need to simply describe your application and resources which are required by your application. So ECS will launch that application as per the configuration you have provided. It will monitor, it will scale your application across like various flexible compute option, whether it is like so these are the various compute options which are available here. So you can spin up your you can run your application on any of these available compute methods. And you can also like perform some operations such as creating custom scaling, or you can create some rules. So you have a lot of flexibility that you can set up that how you want to really behave this application once it is up and running. And you can like some runtime monitoring. You can observe this data, you can make some runtime queries, and you can like query data from your application logs and telemetry, etc. So there is a lot of flexibility which ECS provides on your running application. And we are going to see that in this session today. And like between like the ECS infrastructure, which is EC2 based, or it is serverless, which is Fargate. So which one to use? It depends. Like various criteria is listed here that you can choose. It is based on pricing, because in case of EC2 you will be paying like per hour cost, while in case of Fargate, which is serverless, it is like traditional serverless pricing model that you will pay for the duration you are actually your application is actually getting executed. And then in case of EC2 you get some options to choose the what kind of performance you want. So as you know, like with EC2 there are various instance families, so you have liberty to choose the kind of instance you want to run your application. And then in case of Fargate, there is always some less administrative overhead. You don't really need to manage your EC2 instances, while in case of EC2 you will need to configure and manage each and everything yourself. And so like traditional benefits between like server based and serverless computing, so all same concept applies here with ECS as well.
So if you
Then
go back,
mhm,
so let's take it as a scenario like when to choose EC2 and when to choose Fargate. So there are multiple different use cases and scenario, but most popular is like the pricing, which is like if you're not doing any customize things on your containers, then you can think of running container as a service, which means you will only be charged for the memory and the RAM that your container is using. So it is like a pay as you go model on the Fargate server. Whereas if you run a EC2 machine in the background and then you run your container, but still you are paying the full capacity of a EC2 machine. Whether you're running one container or 10 container, you will be getting a similar cost with an EC2 model. But why to prefer EC2 model is like in case you're doing some specific application which needs a specific type of EC2 AMI, which is a high CPU intensive AMI, or you need a specific GUI specific AMI where you can do high graphics and other things, then it is wise to use EC2, because in Fargate you will get a standard type of instance. You will not be able to choose too much in detail about the underlying hardware. So that is where EC2 is more important to select. But if those are standard containers and you just need them for scaling, then Fargate is a good choice, and it will give you a price saving. In the similar way, you will have administrative overhead, demand and variability. So in case you are running a EC2 it is up to you to manage the scale and high availability of your EC2 instances. You need to set up an auto scaling out of the cluster to make sure like you will have enough resources to run your containers. So it will be an additional overhead for the management.
All
Yeah,
right,
Dipali.
thanks, Rajat. So now let's talk about the various component which are there in ECS ecosystem. So first of all, we have task definition. So if we look at the ECS workflow, so what happens first of all means we have created image of our application and then we have uploaded that image into the ECR, which is Elastic Container Registry. Now your image is there. Now you want to create application. Now you want to run your applications out of those images. So first of all, with task definition, what we are doing, that we are just creating a blueprint of our application where we are just telling that okay, this is my image, and we provide some parameters there that okay, this is how we want to run this image, if there are any like environment variable or something. So we just provide that ecosystem that yes, this my image is this, and these are the things which are needed to run this image. So you just provide a blueprint as a task definition. Now we have not run any container yet. We have just tell our ECS that okay, this is my application and these are the like kind of references which this application is going to use. Now in order to run that application, now in order to run that container, you need to define a task. So task is nothing, it will refer your task definition and it will spin up, it will run an instance of this application. It will run a container of this blueprint which you have just defined in the task definition. Now, in case of service, like for example, you need to run multiple copies of this application, let's say. So you need to run 3 copies, 5 copies of the same application. Then you can actually spin up as a service. So in service, you can simply define that okay, I want 5 copies of five contain. I need to spin up 5 containers of this application, and then you can apply load balancing, etc., onto these applications which you are running. Is application service which you are running. So task and service they are like similar, but in task we are just dealing with single image, a single container, while in service we are dealing with the multiple containers of the same image. Raja, do you want to add something here?
Yeah, so you can simply think it is like task definition is just a definition which describes what things and what port that you are going to export. So it is similar to like defining a Docker file or creating your Docker run command when you run it on your local system. So the parameters that you provide during the Docker run command, the similar parameters you will define in the task definition. And when you run a task, it is just running a task as a container inside your cluster, inside your ECS cluster. And in a service is the slightly difference is like service will give you better orchestration where you can combine multiple tasks within a single service. So if you are running a container for your API and you want to run 3 different tasks, which means 3 containers to high for getting an high availability so that they run on a different availability zone and different subnet, you can manage that via Amazon service, and then you can set up a load balancer on top of it. So for managing that load balancer as well, you don't have to go outside your cluster. Via service as well, you can set up a load balancer, and you can ensure like the load balancer will send the traffic to the 3 or 4 defined tasks within the service. So this is how it is being designed.
All right. So now let's discuss some new features which are available with ECR. Or Rajat, shall we discuss them later, or maybe it cover now?
Yeah, I think it's better to discuss them later. We can cover them later.
Okay. So now it's time to switch on to the demo. So let me stop sharing, Rajat, so you can start sharing.
Yeah, sure. Let me start my screen share.
And while you are setting up, let me just see if we have any questions.
Yeah, so there were a few questions which I tried to answer.
Okay,
So I could
great.
see Aditi. She also joined our previous session. So welcome back, Aditi. It's good to see the repeat audience so that they can get most out of this series because it's in continuation. So I just started my screen share, Dipali. If you can confirm, you can see the screen.
Just a second. Yes, it is visible.
Okay, great. So in a nutshell, what we're trying to do today is like we try to create some images from our previous session. So we have created a special application which is known as tutorial app. We have named it as tutorial app. It has a UI component which is designed in React JS and it runs on Node container. So we in the previous session we have talked about the Docker file. We have shared the source code as well and how to run it on a local Docker instance. And now today we will talk about how to run a package that published to a container registry and run it via the ECS container. So first we will create images on of all those source code that we have. So we have a UI layer, we have a API layer which is designed in Python using the Flask API, using which you can expose REST API, and we are using MongoDB as a database to store our database. So we will discuss that. So there is a prerequisite like you should have a Docker instance running on your EC2 machine. So we have created a EC2 role as well. So let me show those things first because we are not doing these things again here in this session. You can refer the previous video for that session. So first go to the EC2 section where we have a EC2 Linux machine and we are running our Docker there. So if you go to EC2 machine, you should be finding your EC2 instance where you have set up a Docker in the previous session. So this is my machine, ACD ECS demo. And what is the difference I have done in this machine is I am using a IAM role so that I can publish images to the Amazon ECR. So let me go to IAM as well to show that. So there are two ways you can use your AWS access key and secret key as well while registering your AWS CLI, or you can use AWS roles. So we are using AWS role because it is easy to manage. So we have created ACD ECS demo role in which we have provided access for the full permission on the Amazon ECS container. So this is the policy that we are setting up: Amazon EC2 container registry full access. Also, if I go back to the resources link, so this is the GitHub link where we have published all the things that we're discussing today. So this is my app ECS. This is the source code. It contains Docker file and instructions to create a Docker file. Then we have this docx file. This is a Word doc which we have created for you. And in this Word doc, you have all the steps that we are showing today in the demo. So in case you miss something, you can download this document and you can follow all the steps. So it starts from bare minimum, which is like creating an EC2 role. It also talks about how to set up a Docker on your local system. So you can follow this guide as well. And I'm also sharing a Postman collection that we will use to run the APIs from our Postman. So you also need Postman, which is a REST API client tool to test your API, and you need a tool known as MongoDB Compass so that you can connect with your database and you can perform some query. So these are a few things that you need before starting this session. So let me jump over to the session. So Dipali, in case you think I am running a bit fast, feel free to stop me there.
Sure, Rajat. Yeah. But yes,
Yeah, so here,
participants, you please also share the comments if you think it is going too fast.
yeah, sure. Let me share this link in comments as well. So that you guys can have a look at this. Okay, so let me grab the public IP of my machine and then let me run a tool named Putty so that I can connect to my EC2 machine. You also need a key pair. So I have already created one. Okay, so this is a blank machine. What I have done is like I have created a blank machine and I have just installed Docker on this machine. which you can follow the guide or the previous session. Now we will talk about how we can download the source code and how we can start playing around with it. So before playing around with the source code, let's move to the container registry on ECS. Let's first create a container registry because it takes some time, like 4 or 5 minutes in the background, and by that time we will be creating our images on the EC2 machine. So if you go to the services on Amazon, look for ECR, Elastic Container Registry, and then I'm inside my Mumbai region. So these all the registry ECS cluster are specific to a region. So it is important to decide the right region before you start setting up the resources. So here I'm using Mumbai region. So now in the create repository, you can see we have a private and public option. So by default, I'm creating private. So you can see like it is using my Amazon account ID as well as the region ID along with it, so that it ensures like it is specific to my account and a specific region only. So this registry, if I'm creating it as a private, will not, if I'm using this registry in the other region, it not be available in the different region. So I want to create two registry. One is a tutorial UI for keeping my UI stuff. So the best practices or the recommended practices to define a repository specific to your images so that you can manage multiple version of that image only. That is the recommended guideline from the containers and the Docker. So I'm creating a tutorial UI repository. So you can see like it is created, and this is the URI which we got. And in the similar way, let me try to create a tutorial API as well. So I'm naming them along with the image name so that it will be easy for me to recollect which repository is used for which image purpose. So sometimes it takes few minutes to publish data to this images. So let's go to the Docker stuff and then download the source code and run it. So source code is available on the GitHub, so you can download the source code from GitHub link that we have shared, or we have also published this onto S3. So this S3 link is there. You can directly download it from there as well in case you don't want to play around with the GitHub. So you can go to your EC2 machine. You can use wget command, which will simply download this file. And now once it is downloaded, you can run ls command to confirm the source code is available. Now you need to unzip is. So let me unzip this here. So if I go to my folder, so I can see like I have a front end folder, which is the front end UI application. I have a backend folder, which is the Python API source code, and then we have a Docker Compose. So you can think, you can talk about, look for the previous session to know about more in Docker Compose, how you can run the service inside a Docker container on your EC2 machine in the previous session. So let's go to front end. So here also you can see like we have a source code which is under src folder. We have a source code and the package JSON for the React application and some images as well. And the most important thing is like we have a Docker file. So we need Docker file to create the image for this application. So let me first run Docker images. So right now we don't have any images in our Docker environment. So first create a UI image. So I have just taken a note of these commands for quick reference for creating these images. You can find all these commands in the Word doc that is available on the GitHub. So you just copy this command, which is docker build. So docker build is for creating an image. We want to use dockerfile dev inside the source folder, and we want to name that image as tutorial UI, and we want to create it on the root folder. So this is what this command is doing. So this command first go to the Docker file, it reads the content from there, and it downloads the base file, which is specified base image, which is specified in the Docker file. Then creates the, it runs the command that we have shared. So what we are doing is like we are copying the package JSON and other source code to the slash app folder inside a Docker container, and then we are installing a npm which will be used to run the application. So this step can take some time if you're doing it for the first time, because it downloads the image from public internet. So it depends upon the internet speed and also your speed of the system where you're running it. So for first time it takes some time, but second time it will be much faster because it do a cache and manage everything. So Dipali, are you able to see the screen share that I'm doing? Dipali, you there? Okay, looks like some issue with the screen share. Let me try to do it again. I'm sharing my screen again. Okay, I hope it is visible now. So just to recap, I have gone to Elastic Container Registry and created two registry, one for tutorial UI, another one for tutorial API. And in my EC2 instance, I am running a command which is like docker build -f dockerfile.dev, and I am trying to create an image so that I can create an image and publish. So typically initially it can take some time, 3 to 4 minutes, because this is the first time we are doing it, and it takes time because it is installing images, then it is installing a tool on the images. So meanwhile, if you have any questions or queries, you can post your queries. Okay, looks like some issue with the screen share again. Let me try to stop and start again. So I'm starting a new screen share again just to check if it works fine. So looks like my EC2 machine is not getting shared somehow. Let me try to share that again. Okay, I'm trying to share another screen. Yeah, looks like still no luck.
Rajat, am I audible now?
Yeah, Dipali, I can hear you. Looks like you
Okay.
got dropped off.
Yes, yes, there was some power disruption. And yes, I just shared your EC2 machine into this one. So I think now you will stop sharing.
Okay, looks like the issue was you got dropped off. The screen sharing was stopped.
Sorry, my bad.
No, no, no worries. It happens. So I started a screen share again.
Hmm.
If you can confirm the screen is visible,
Yes, we
especially
can
the Docker
see.
screen.
Yes, we can see both.
Okay, great. Thank you. So I just ran a command to create a Docker container, a Docker image, but looks like it is taking time. Yeah, so we are almost there to complete the creation. Okay, looks like screen again gone.
Yeah, EC2 screen is not visible currently, but yes, console is something we can see. We can see EC2 now.
Okay, so looks like when you drop off from the stream there, then it's stopping the screen share. Okay, no
Uh,
worries. So now we have a front-end image created, so we can run command docker images to confirm the image name. So we have a name created tutorial UI, and we have a image ID also present. So now if I uh, go back and I want to create a image for my UI, so let me try to create a image for UI. So this is the command that I can run to create a UI image. So I need to go to my backend folder first, and I just need to build a image. So I'm going to backend folder, and then here I'm running a command which is like docker build minus t tutorial API, and I'm going to run a command. So is my screen visible now?
yes, Rajat.
So I just ran a command. Okay, great. So again, it can take some time because we are doing it for the first time on this machine. So it first downloads the base image, which is generally in size of 500 MB or 600 MB. And so there are multiple techniques like using which you can reduce the size of your image that we can discuss further in the detail in the coming sessions, and how to reduce the size of your image so that it will be easy to package and distribute. Okay, so now this has built successfully, and now we can run docker images to confirm the images that we have. So we have UI and API images ready. Now what we will do is like we will go to ECS container registry, and we will publish our image to API. So if we go to the API repository, right now this is empty. So you can click on view push commands to publish the images to your repository. So you need to follow these commands. So this is the first command where we are doing a login. You can copy this command as is. So you need to pre-configure your AWS CLI, or you need to use an AWS IAM role the way we have used, so that you can make a connection with your AWS account. Otherwise this will not work. So we can see like login is succeeded. Now we go, this is for building the image. So we have already built the image. Now we want to tag the image. So what is the tagging of the image means is like you are doing a versioning with your image. So by default, it follows a naming convention of latest, which is like the last updated image. But what we are doing is like we are using 1.0.0 version so that we can specify a version 1 for our image. So latest tag means like when you're using GitHub, you will be always on a main branch for your source code, which means like it is the updated code. In the same way, latest is the image which is the last updated and last active image in your repository. But instead of latest, we're using a specific tag 1.0. And now we want to push the image. So this is the command docker push, and the image name that you want to push along with the version. So here also we need to update the version to 1.0.0. So it will now upload the image from your local system or your EC2 machine to the Amazon container repository. Here you can see like it has distributed a upload in multiple threads. So once all the threads are completed, your image will be successfully uploaded to Amazon registry. And this registry is available only within your own account, within your own AWS account. So if you have connected a VPC and a connection from your organization to this Amazon account, then these registry and the images will be available within your on-premise organization as well. So now this is successfully updated. So we can go and refresh. So we can see like 1.0 version is successfully updated for tutorial API. Now we'll go to the UI and we will follow the same steps. Login, we don't need to do. Image building, what we don't need to do because we have already done that. And now we just need to tag our tutorial image. Again, I want to give this as a tag as 1.0 and we can push it again. So once this image will be pushed, we'll be good to go. So meanwhile, we can go to the ECS container because that
So,
also takes some time to create.
Rajat, sorry to interrupt here.
Yeah.
So before you move on to ECS, can you quickly recap what you did so far as part of this demo? Because yes, there were interruptions due to screen share was lost.
Okay, sure. What I have done is like I have used my EC2 machine where I have created the images, which is Docker images. So these are the same step that we followed in the previous YouTube session. So in case there was a screen issues, you can refer the previous session as well, how to create these images. And all the guide is also available on the Word doc. So in case you miss something, everything is available. And then the additional step we did is we log into our ECR registry and then we have used tagging. So we tagged our images with the name of our AWS account URL, which is being provided in the repo name. And then we publish these images to ECR so that these images will be available inside ECR, which we can use in the while running the ECS container. So you can also publish these images to Docker where you can have a secure connection or you can publish it to the public Docker as well. You can use that also into the Amazon Elastic Container Service while creating your container. But to be more specific to AWS account and to make it more secure, we are using Elastic Container Registry as a component for hosting our images.
Yeah, and just to reiterate, like ECR is very simple. So you just need to create, you need to navigate to ECR service. You just create your repository, and then on the EC2 machine where you have created your image, if you click on that registries like view push commands, so it will show you the commands through which you can push your images from EC2 to your ECR registry. So it can be EC2, it can be your local machine, anything. So you just need to follow those commands and you will be able to push images into ECR. Sorry,
Yeah,
Rajat, carry on.
no worries. So let's go to the cluster part. So we want to create a cluster first, and then we talk about a sequence. As Dipali mentioned, we need to create a task definition, then we need to create a task, and then we need to run a service. So that is what we want to follow now. So first create a cluster. This can take some time. So I'm just naming it as dev cluster. You can keep separate cluster for your dev environment and your uh, prod or non-prod environment, or you can use this cluster per application basis as well. Keep in mind like there is a separate cost for cluster as well in Amazon. So therefore the pricing policy, there is an additional cost when you set up the ECS cluster along with the underlying hardware infrastructure that you use. So you can use cluster which is based on AWS Fargate, or you can use cluster based on Amazon EC2. So as we discussed earlier, so I would recommend to use Fargate for this demo because it is simple and easy to use. But based on your requirement, based on your organization requirement, you can use Amazon backed instances as well. So we are keeping rest of the things by default. You can enhance monitoring, you can set up a separate custom key for encryption as well. It depends upon your requirement. So we are just creating a simple cluster now. Again, it can take some time, 3 to 4 minutes. So by that time, Dipali, if we have any questions on, we can reply to those questions. So Dipali, if you can read the questions from there, from the chat. Dipali, you there? We can't hear you. Yeah, looks like she got dropped off. So let me try to read some questions if I can do in parallel. Okay, so there is a question which is not answered yet. Is a question for how about running? It's from Rohit Tewari. How about running stateful services in ECS? So ideally, the Docker container, the Docker concept, and the container concepts is running the stateless
Rajat,
services.
am I audible?
Yeah, you are audible now, Dipali. Looks like you dropped off. Yeah, we can hear you now perfectly fine. So majorly this is designed in a way like it has to be stateless, because if your the clusters and your containers can go down and they can be built up and scaled up automatically. So that is where it is more preferred architecture for the stateless things. But you can also do stateful application, but you need to ensure like you need to use tools like load balancer. Then you need to set up the sticky connection settings on the load balancer. This is one way. Other is like you need to use EBS backed your ECS backed systems and is EBS backed volumes, so that whatever data you're persisting will remain on the EC2 host in the background. So there are techniques still you can configure, but it is more suitable and more native for the stateless applications. So looks like our cluster is ready, and now we can go ahead. So if we go inside the cluster, we can see like we get an option to define services and task. But before that, we need to go and define a task definition. So first, let's define a task definition for the database. So we will follow a bottom-up approach. We will set up a database first, and then we will create API layer, which can set up things on database. So that is from where we go. I hope you guys can see my screen, or it is still kind of a frozen. Okay, I think yeah, screen is working. So let me try to create a MongoDB task definition. So I'm giving name as MongoDB task dev. And then again, it'll ask me for the infrastructure requirement. So I will stick to the AWS Fargate as the underlying platform for providing the CPU and RAM. I'm using defaults for CPU and memory. Here you have an option where you can change the instance type. You can provide more CPU instance and more memory. You can also choose the underlying I would say the EC2 configuration, which is Linux based or Windows based in case you're running Windows container. So I'm keeping to default. Then there is a option of a task role. So in case you're writing any code in your APIs which wants to connect to other AWS services like S3 service or DynamoDB server, then you need to define a task role with the permissions of accessing those services. So here we are not using any Amazon service. We are just using MongoDB and we are using a API layer. So there is no need to define a task role. And now here comes the container specifications. So we are setting up a MongoDB container. So I'm setting up the specific settings for MongoDB. And now for image URI, I want to refer to the public image which is provided by Docker Hub. So this is the way you can define. So by default, it is connected to the Docker Hub. First, if you do not specify any URI, it goes to the Docker Hub and scan the public repository. And I'm defining the version as 7, which is Mongo version 7. It is known as tagging as well. And now I want to specify the port. So by default Mongo works on 27107 port, so I'm specifying that port. So remember that you need to expose this port in your security group as well, so that you can connect to that instance when you want to make a connection. And within environment variable, I want to set up few variables so that we can set up the username password at runtime. So for Mongo, I want to set up this variable name Mongo init root username and root password to specify the username and password for my Mongo. You can also connect it with the AWS service for securing these variables and providing this at runtime from the security manager, Amazon security manager, rather than writing hard coded values here. So I'm using admin and password for my configuration. Then I'm keeping rest of the configuration as default and creating a task definition. So you can see task definition has created successfully, and it has created a version 1 for it. So it by default manages the version for your task definition in case you do any updates. So now we go to another task definition and define for
Sorry, Rajat, sorry to
yeah,
interrupt there.
Deepali.
And I'm sorry, I was again facing some issues. So
No
I
worries.
can see a consistent message from Tushar that he is not able to follow. So Tushar, can you please send a latest comment if still that is the case, and we should do a quick recap of the step, or please let us know if we are good by now. Rajat, you can continue while we receive some message from Tushar.
Okay. So again, in case you miss something, so all the things are documented, well documented in the Word doc. So you can go and follow that as well in case you are missing the documentation.
Well, Tushar
So
has
in
confirmed that now it is good to go.
okay, great. Thanks, Tosha, for the updates. So now in the same way, we are defining our API container. So in our case, API container, we are naming at API. And for the image URI, now we need to go to the container registry for the API container repository. So now we have two repository for API and tutorial UI. We need to copy this URI because this is specific to our account, and we can provide a complete URI here along with the tag name. So if you remember, I have given tag name as 1.0.0. So I want to use that tag. And for my API, it's a Python API which is working on port 5000. So I'm exposing port 5000 on the container so that we can connect to the service. And in the environment variable, now I want to pass the credentials for my database, the host name for my database, first of all, so that my API can connect to it. So I'm keeping it as MongoDB host. And for now, we can see like we need to provide a IP of Mongo container. So Mongo container, we have not created a Mongo container as of now. So we don't know the IP address for my Mongo container. So it will be available when we create a Mongo container. So we can provide and override that at the time of running the service. So for now, we are just defining the thing. So let's define it in this way. And now I want to pass my Mongo username. So I'm defining Mongo username and Mongo password. Again, these things can be, you can override them at the time of running the container. So I'm providing defaults in case we want to use default, and we will just override the Mongo container private IP address. Again, rest of them I'm keeping default and creating the task definition. So we are ready with the task definition for Mongo database and API. Now we need to define a task for the UI. So in the same way, we will follow the similar step. Tutorial UI task definition. I'm just using task def in the name so that we can easily relate to it later on in case we need it. Keeping default. So I here I'm giving name of UI, and I need to provide the URI for my UI image from my repository. So if I hosted it on public Docker, I can provide that as well. So there is a way to provide private authentication as well. So if you link here, there is an option like you can provide credentials, you can store the credential in secret manager, and you can provide a link to your private registry for authenticating and downloading the private content. But as it is private to my AWS account, so I don't need to provide any additional configuration. And for my UI, it is running on port 8081 by default. So I'm running on port 8081 for port mapping. You can define multiple port if you're exposing multiple port from your application. The similar way you can run it via docker run command. So you can do that as well. Rest I'm keeping default. One more thing I need to define here is a React API URL. So when my UI runs, it wants to connect to a API. So I need to provide a API URL where API is running. So we can provide that later. And for API, we want to provide a public IP of my API endpoint. So you can think around it like why you need a public IP of API endpoint in UI, whereas in API we are defining a private IP of Mongo. So this could be a question. If someone answers it right, they'll get a AWS credit, and we will explain that later when we create containers. Okay, great. So we're ready with task definitions, and now we can run to the go to the cluster and start running our task. So this is my cluster, and I want to run a task first. So you can run task as individual, or you can create a service and you can run a task under service as well. So for simplicity, we are using task as of now, and you can explore services later. So first of all, we want to run a task for MongoDB. So we created a task. We are using a default capacity provider, and we are using Fargate for example. And now from the family, we need to select the task definition that we have created. So here we want to use MongoDB task definition. If we have multiple revision, you get all those revisions and you can select the one that you want to run. So we are keeping default as of now. And now if we go to the container overrides inside Mongo, we will get an option to override the environment variables that we have provided earlier. So as I don't want to change them right now, I'm keeping them as default, but you can override them as well whenever you want. So with this, I just created my MongoDB task, and we can go here. We can see like it's in provisioning state. It again take few minutes, like 2 or 3 minutes to get started. So it is similar like running a docker run command that you do it for running a Docker container. So in the same way, it is creating a container now. So the status is pending as of now, but yeah, it should be running very quickly. Yeah, so it is running now. If we go to the settings, and we can get the public IP of my MongoDB database if I want to connect. And before connecting, I need to ensure like I have allowed the ports in my security group. So if I go to the security group, this is the default security group which I'm using. You can define your own security group, but for my case, I'm using a default security group for all my services, all my containers. So if I go to security group here right now, no inbound port is open. So I need to go and open the port for MongoDB database, which is 27017, and I want to allow traffic from anywhere. I want to add a rule for 5000 port for my API. Again, I want to allow access from anywhere. And the third rule I want to apply for port 8081, which I only want to allow for the browser based access. So all these ports I'm opening. Based on your security requirements, you can configure the IP range and the accessibility for your specific subnets or specific security groups for enhanced security. But for the demo, I am keeping all open. Okay, so security group is updated. Now we can copy the public IP address, and we can use a tool like MongoDB Compass. This is a client to connect MongoDB database. So I need to provide the IP address, public IP address of my MongoDB database to connect, because I'm running this tool on my local system, which is my laptop. But if you're running from your EC2 machine, then you can use a private connection as well, because that is within your account. So I'm using a username password based authentication, and I'm providing admin and password, which are used while defining the variables. So if I click on connect, it should connect to my database and open the console. So we can see like it has successfully connected, and we can see a default database which is there. So let's let it be there as it is, and we'll come back to it later. So we have successfully running our task for the MongoDB database, and before running the task for API, we need to copy the private IP, as we need to provide it during the running the container for the API. So now we go and run the container for API. So we are selecting API task definition. Everything we are keeping default, and then within container overrides, you can see like in the MongoDB host, we need to override with the private IP address of my MongoDB. So here I am providing a private IP address so that it can privately connect to my database, and I can remove the security group for the public access, because they can connect on private, then it to be make it more secure. So just for the demo purpose, I have used this MongoDB Compass to show it. That's why I opened the public port, but otherwise there is no need to open a public port within the containers if you want to access database within the containers. So I'm creating a task for my API as well. So again, it can take some time, 2-3 minutes to run a task. Usually it is very fast, like the way you run it on Docker container, but Amazon performs some health checks before making that live. It performs health checks and other checks on the Fargate uh, Fargate database pool, so that it takes some time. Okay, so here you can see like which task definition these containers are using along with their version. So now this is also running. So if I go here, I can again grab the public IP, and I can use a tool like Postman to confirm my API is running or not. So I have defined a health API endpoint, and in this I can change the IP address, which is the public IP address of my API container. And if I update it and run it, it should be returning with the services up and running 200 response. So in the same way, we can go and get the tutorials, but yeah, let's try to create some data first. So I have a sample JSON model, and this collection is also provided in the source code. You can use that. So we want to create a book named Harry Potter, just a first book that we want to create. So we can see like tutorial has been added successfully. And if I go to my MongoDB database and if I refresh, I can see my Python code has created a tutorials database along with the tutorials tab for the table data. And now it has created a book named Harry Potter via the API access. Great. I hope everyone is able to follow. Moving further, now we have a public access of my API, and I want to create a UI layer for my application. So I again go to the task, define a task, new task for my UI application. I am picking up the task definition for my UI application, and I want to override containers, and I want to provide a public IP of my API endpoint. So I'm providing a public endpoint where my API is running, and let's create it. Okay. So again, it can take some time. So now you have seen like we have not defined any of the specific rules, auto scaling and other things on the task that can be managed via service. So in the service, when you define a service, you can specify how many minimum instances of task you want to be keep running, in which availability zone you want to run those tasks for high availability. You can do all those configurations in service. And if you define multiple tasks of the same image, you need to define a load balancer so that load balancer can shed the load on those specific instances in running containers. So now you can go and you can again grab the public IP, and if you open your browser you need to put http, because I'm running my services on http only. It's not, they are not secure, and they're running on port 8081. Okay, here it is. So you can see my application is running and it is showing a pre-populated data for the Harry Potter book, which I pushed via Postman tool. Now we can use GUI to add more data. So let's push data, some dummy data like Java. Okay, so I can see like my UI application is working perfectly fine. I can perform complete CRUD operations, like I can edit the description or I can publish the book. The details of the book now been marked as published. Earlier it was being marked as, by default it is being marked as pending. So you can perform all these operations, and again if you go to your database and if you refresh the database, you can see like it's pushing the database data to the database as well. So it is like from UI it is going to the API layer, and API layer is pushing data back to the Mongo database. This is how this application is working. Okay, anyone would like to answer why we have provided public IP address while running the UI container for the API? Dipali, you there? If you want to take up some questions from chat.
Yes, Rajat. Yes. So I'm just showing some questions on the screen. So Sanchit has asked how we can securely connect from our VPC to ECS APIs.
Okay, so right now I'm using everything as a public IP, but in case you want to set up a secure access, so while creating a cluster, there was an option to switch off the public availability of the cluster. So if you switch off that, it will be only available on the private IP addresses. So if you set up a VPC, so either you can set up a EC2 machine within the same VPC from where you can configure and access your things, or the other option is like you need to use a tools like VPC gateway or VPC, AWS VPC Direct Connect to set up a secure connection from your local machine or your enterprise application to AWS account, and then you can play around and access via the private IPs only.
Okay, and then there is another question from Ashraf. What is the underlying technology used in here to create ECS? To create AWS VMs and containers like OpenStack.
Okay, so I don't know much of the details, but I'm sure like Amazon, it's using its own way of creating the setup, because Amazon is a big organization and they have their own tools. They might be using some public tools like that had OpenShift or OpenStack, but yeah, it is not public. So for Fargate, they're managing it in the background for us as a pool of resources, which has pre-created EC2 instance, pre-installed Docker engines. So that is how you can take it as of now. But yeah, we can dig down into more detail if it is available anywhere, like what is the underlying cloud mechanism they're using. So I'm not aware about it.
Okay, Richard. Next question is, are these services free to use or not?
Yeah, so as I mentioned, there is a separate cost for running an ECS cluster. So ECS registry also has its cost when you upload a data. So there is a free tier available as well, like up to 20 GB as I remember. It's free in ECR, but if you exceed that limit, you have to pay. For cluster, there is a separate cost whether you use it or not. And if you use instances in the background which is Fargate based. So till the time you're running your containers, that configuration will be charged. But if you're using EC2 backed instances for your cluster, then you have to pay the cost for the EC2 instances as per the on-demand model. So you can also use spot instances, but again, like they are not guaranteed. But you can use your spot instances as well.
Okay, so is if there is any question which is like left unanswered through chat or from Rajat, so please post that question again in the chat. And Rajat, I think Tushar has responded on the question you asked. So he has responded that no internet gateway or net gateway defined, and that's why public IP address for API probabilities. And so the question you asked, he's trying to respond on that.
Great, that's good.
Okay, Rajat,
Okay,
back to you. No pending
yeah.
questions so far.
Okay, you can go back to the presentation mode, Dipali. I've
Okay,
stopped my screen share.
sure. But do we have any slides left there?
I think just the next features, new features, those were
Okay,
left.
okay. Yes, yes. So you can see my screen, right?
Not yet.
No? Should be visible, Rajat.
I'm getting a blank screen.
Blank screen. Okay, let me stop and share one more time. How about now? Are you able to see?
Yeah, I can see the screen now.
Okay. So yes, these are the new features slide.
So in ECR, we talk about creating a basic definition, task definition, and then running a task and service based on those task definition. So uh, there are new features which is like ECS task placement, using which we can place a task on specific availability zone and other things. So that is what we can use in task placement. Then we have IAM role for task as well. Like for each task, we can define a specific task role. I have shown that like if our database or the API layer is connecting to the DynamoDB database rather than MongoDB database, we can define a specific task for each role so that it can only connect to the DynamoDB database for the API. We can define scaling and performance options as well based on auto scaling and load balancer that is now built in with the ECS. We can also then we can even stream logs to CloudWatch and other systems so that multiple containers are generating logs on the same stream where we can search and we can do the debugging for the further, and we can even schedule the deployments. Like in case we publish a new version, we can schedule a task deployment as well using ECS. So these are with some of the new features that we can explore other than the standard task and service management. These are the resources. Again, we have shared the link already in the chat, private chat, and the YouTube. So you can refer the links there, or you can go to this GitHub repository which I have set up, and you can get all the resources, which is source code. There's a document, Word document, which has all the steps defined, properly defined all the steps, and it has a sample for my Postman API as well. So you can import that and run that API in your Postman as well.
And this is the QR for the feedback on this session. So please do share and please do share your feedback because so far we were not capturing feedbacks for any virtual sessions, but I think it is important to consider that as well. So please try to be descriptive when you're sharing. So yes, because in virtual sessions we don't get much opportunity to interact with you, so please try to be descriptive so we can actually consider and make it more relevant in for you guys in future sessions. And on the active participation side, so like when you are like mentioning feedback, please do provide your correct emails so we can share the credits to the active participants which are captured as part of this feedback.
And also follow this series. So we will be upcoming with the session on EKS. So the same example, we want to run it in an EKS, and we'll show how you can scale up from normal containers to a high scalable Kubernetes environment. So stay tuned to this space. Maybe we'll do this session after 2 weeks. So keep watching the space and register for the upcoming session.
Yeah. And in case you have missed any session or even for today's session, please spare some time to do these hands on yourself. Only then you will like feel confident and you will be able to relate things and it will like add some value. So
So with that, I think yeah, we're good to
let
close.
me paste the like this feedback link as well. If it is. So so this is the feedback link. I'm just pasting it on the comments in case you are not able to scan the QR. So yes, for like next session, this for sorry for this session, active participants, I would like to call out Tushar, Sanchit, and there was another good question from a participant, Chinna. So these three are the people who are going to receive AWS credits out of this session. So make sure you are mentioning your correct email IDs. With that, I think we are good to wind up now. I don't see any pending question. But in case there are any further questions, so please feel free to post them on Meetup or on YouTube. Thank you so much.
Thank you, everyone. Thanks, Dipali.
Thanks, Rajat.